In this video, we upgrade your zones using the Karvonen formula. Let's move beyond simple percentages of your max heart rate reserve, or HRR, is the difference between your engine redlining and idling. While episodes 2 and 3 covered finding your max and resting rates, HRR combines them to define your specific, workable capacity. This metric gives a much clearer picture of your actual engine size because it accounts for the efficiency gained through training. Why bother with the extra math? Because the standard straight percentage method ignores your fitness baseline. If you and a beginner both have a max HR of 190, but your resting HR is 45 while theirs is 80, your physiologies are fundamentally different. The standard method treats you exactly the same, which often results in undertraining for fit athletes and overtraining for beginners. Enter the Karvonen formula, developed in 1957. Instead of taking a slice of the total pie, we calculate the percentage based on your reserve and then add your resting rate back in. This scales the intensity relative to your available bandwidth. Crucially, this makes your training zones dynamic. As your fitness improves and your resting heart rate drops, your training zones automatically adjust. Let's plug in the numbers for a Zone 2 run at 70% intensity. Our runner has a max HR of 190 and a resting HR of 50. First, we find the reserve, 140 beats. We take 70% of that reserve, which is 98, and finally add the resting 50 back in. The resulting target is 148 beats per minute, customized specifically to this runner's physiology. Here is the critical difference in the data. If we use the basic straight percentage method for that same runner, 70% of 190 is only 133 BPM. That's a 15-beat discrepancy. Using HRR pushes the target higher because it acknowledges the runner's efficient resting heart rate. This aligns much closer with laboratory ventilatory thresholds, ensuring you aren't plodding along too slowly to elicit adaptation. However, nuance is required. While studies suggest HRR correlates better with VO2 max, the formula is brittle if your inputs are wrong. If your max HR is estimated via age formulas rather than field-tested, the error margin magnifies significantly. Use the Karvonen method only if you have reliable, tested data for both your max and resting heart rates. Otherwise, the precision is an illusion. Up next, we explore lactate threshold testing methods.